What if I told you the best place to find alien life isn't Mars, and it's not even a planet? For decades, we've been staring at the red dust of Mars, convinced it's our best shot at answering the biggest question in human history. Are we alone? But here's the twist. Some of the strongest evidence for potentially habitable environments in our solar system isn't on rocky planets at all. It's locked beneath thick ice, hidden in dark oceans, on distant moons orbiting giant planets. And that changes everything. Because on Earth, wherever we find liquid water, we find life. Not sometimes, not occasionally, always. From boiling hydrothermal vents at the bottom of the ocean to frozen Antarctic lakes buried under miles of ice, life finds a way. So when scientists discovered entire oceans beyond Earth, the conversation shifted from if to what might be swimming there. Let's start with Europa. Europa is one of Jupiter's largest moons, slightly smaller than Earth's moon. Its surface looks like a cracked eggshell, vast plains of ice crisscrossed by reddish-brown streaks. For years, scientists suspected something extraordinary lay beneath that frozen crust. Now we have strong evidence that under 10 to 30 kilometers of ice, there's a global ocean. An ocean that may contain more than twice the amount of water found in all of Earth's oceans combined. That's not speculation. That's based on data from NASA's Galileo mission, Hubble observations, and more recently, the Juno spacecraft. Magnetic field measurements suggest a salty, conductive ocean beneath the surface. Even more exciting, the Hubble Space Telescope detected possible water vapor plumes erupting from Europa like geysers blasting material into space. If confirmed, that's a game changer. Because instead of drilling through kilometers of ice, a spacecraft could potentially fly through a plume and directly sample the ocean's chemistry. Now here's where it gets controversial. Europa is incredibly far from the sun's surface. Temperatures hover around minus 160 degrees Celsius. No sunlight reaches the ocean below. So how could life survive? But that question assumes life needs sunlight. On Earth, entire ecosystems thrive around deep-sea hydrothermal vents where sunlight never reaches. These organisms survive using chemosynthesis, deriving energy from chemical reactions rather than sunlight. If Europa's ocean floor has hydrothermal activity, fueled by tidal heating from Jupiter's immense gravity, then the ingredients for life, water, energy, and essential chemicals, may already be present. NASA's Europa Clipper mission, launched in 2024 and expected to reach Jupiter in 2030, will perform detailed flybys to map the ice shell, analyze the ocean's chemistry, and search for biosignatures. Not fossils, not bones, but chemical fingerprints that life tends to leave behind. Now let's move even farther out to Saturn's moon, Enceladus. If Europa is promising, Enceladus is shocking. This tiny moon, only about 500 kilometers wide, was once thought to be a frozen, dead world. Then in 2005, NASA's Cassini spacecraft saw something astonishing. Massive geysers erupting from its south pole, spraying water vapor, ice particles, and organic molecules hundreds of kilometers into space. Let that sink in. Enceladus is literally spraying its ocean into space. Cassini flew directly through those plumes multiple times. It detected salty water, molecular hydrogen, carbon dioxide, methane, and complex organic compounds. In 2017, scientists announced something even more compelling: evidence of hydrothermal activity on the ocean floor. Molecular hydrogen in the plumes suggests chemical reactions between water and rock, similar to hydrothermal vents on Earth. And on Earth, those vents are teeming with life. Here's the pattern erupt. Enceladus may currently have the most accessible habitable environment beyond Earth. Not in the distant past, not billions of years ago. Right now, no drilling required. The ocean is venting itself into space. That's why missions are being proposed to return and directly analyze plume material with advanced life detection instruments. Some scientists argue Enceladus may actually be a better target for life detection than Mars. Now let's talk about Titan, Saturn's largest moon. Titan is bizarre. It's the only moon in the solar system with a thick atmosphere, primarily nitrogen, like Earth. It has rivers, lakes, and seas, but not of water. They're made of liquid methane and ethane. At minus 179 degrees Celsius, water on Titan is rock-hard ice. Yet beneath its icy crust, data from Cassini indicates another global subsurface ocean of liquid water mixed with ammonia. But Titan adds another layer of intrigue. Its atmosphere is rich in organic chemistry. Sunlight interacting with methane produces complex carbon-based molecules that rain down onto the surface. Some scientists speculate that Titan could host a completely different kind of life. Life not based on liquid water, but on liquid hydrocarbons. Now, to be clear, we have zero evidence that such life exists. But laboratory experiments show that complex prebiotic chemistry can occur under Titan-like conditions. NASA's Dragonfly mission, scheduled to launch in 2028 and arrive in 2034, will send a nuclear-powered drone to fly across Titan's surface, analyzing organic chemistry and searching for clues about prebiotic processes. Even if Dragonfly doesn't find life, it may reveal how life's building blocks form in alien environments. And we're not done. Ganymede, Jupiter's largest moon, is bigger than Mercury and has its own magnetic field. Data from Galileo suggests it may contain multiple layers of oceans sandwiched between ice. Callisto, another Jovian moon, is also suspected to host a subsurface ocean. Even distant Pluto shows evidence of possible subsurface liquid layers despite its extreme cold. Here's the controversy no one talks about enough. We may have been planet biased. For generations, we defined the habitable zone as the perfect distance from a star where liquid water can exist on a planet's surface. But ocean worlds break that rule. They don't need to be close to the sun. Tidal forces from giant planets generate internal heat. Radioactive decay adds more warmth. Ice becomes insulation. Liquid water can exist far beyond the traditional habitable zone, which means habitable environments might be far more common in the universe than we ever imagined. Recent exoplanet research supports this idea. Astronomers have identified numerous icy moons and water-rich exoplanets. Some estimates suggest that subsurface ocean worlds could outnumber Earth-like planets in our galaxy. Let that sink in. The most common habitable environments in the Milky Way may not look like Earth at all. They may be dark, ice-covered oceans orbiting gas giants. But here's the hard truth. We still have no confirmed evidence of life beyond Earth. Not on Mars, not on Europa, not on Enceladus, not anywhere. And that's important because science demands proof. The next decade will be critical. Europa Clipper will map Europa in unprecedented detail. Dragonfly will explore Titan's chemistry. Proposed missions to Enceladus aim to directly search for amino acids, cell-like structures, and isotopic ratios that could indicate biological processes. If we detect even simple microbial life in one of these oceans, it would mean life emerged independently at least twice in our solar system. That would strongly suggest life is not rare, it's cosmic. But here's an even bigger twist. If we don't find life, despite all the water, chemistry, and energy, that might be just as profound. It would mean that life requires something extraordinarily rare, something we don't yet understand. Either outcome reshapes our understanding of existence. So the next time someone says aliens must be little green men flying in saucers, remember this. The real aliens, if they exist nearby, are more likely microscopic organisms drifting in a pitch-black ocean beneath kilometers of alien ice. Silent, hidden, waiting, and within our lifetime, we may finally know. If exploring the greatest mystery in the universe excites you, follow for more deep dives into space, science, and the discoveries that could change humanity forever. Now tell me, if we discover microbial life in one of these ocean worlds, do you think it will unite humanity or divide us?